Hey guys, so today you and I are going to talk about packed together pieces of code. So let's get into it. So the question in question was, Frederick, how would you differentiate between an engineered piece of code versus a hacked together piece of code? Well, I would measure it based on how well does it fit how well does it model the solution needed to solve the problem that we are dealing with. So usually when you have people who don't really do so well in software development, or people who don't really understand what they're doing, what you will see is that the software solutions that they make are either very complicated, the ones they have spent more time on, this is like the main difference I would say between like a junior and a mid-level philosopher and a true senior. So usually with the mid-levels like this, like the philosopher software developers who make everything very complicated, you will very quickly see that most of their code it takes some pattern that they have figured out, like a classic one that I see. I work with code that like that actually now, where we have a software developer who was very into the dry principle. Everything is supposed to be super dry. So what he has done is to basically create an interface that is a derivative of another interface that is a derivative of the third interface. It just goes in layers, right? And then he uses, in this case, it's TypeScript, so he just uses tons of like omitting and picking, and then like he basically tries to, it's almost and he has a functional gene as well, so he tries to compose together new interfaces derived from other larger interfaces. And the end result is that the code is actually very painful to try to understand. Because if you want to figure out what something actually does, what the interface actually is, you can't just look at it, which is sort of the whole point. You have to go into multiple layers of abstraction to figure out what the thing actually has. Or you can do what I have learned to do, just use the autocomplete and then just list all the properties, which is what it should have been doing if it was a simple solution that fit the problem, right? That is a very common pattern, and what happens there is that you basically have to rewrite this because it creates it follows a principle, but it actually causes comprehensional issue, like it makes the code difficult to maintain, which is, as I've said to you guys before, if you have a design pattern that makes it more complicated for you to reach the goal that you're trying to reach, then this is not a good design pattern for this situation. It might have been a super good design pattern for somewhere else, or if you used it in a different way, but if it's causing pain and reducing development velocity, then it's not a good pattern to follow. And the same thing goes for the absolute juniors. When you see a junior implement a piece of software, and the most common one is that you have and this is not just true for the juniors, it's also true for people who are even more experienced software developers who don't really have a talent for software. Something that I've said to you guys before, the fundamental thing that you should understand about being a software developer is that you have your primary function as a coder is to take a problem or a conceptual problem or a physical problem or something like that and model that in code and reach some sort of goal. In other words, your code should reflect a fairly simple and well thought out solution to the domain problem that you're dealing with, which is what we call our problem domain, right? The thing that you're actually trying to do. So if I look at your code and it's if the code is not, if I can't really figure out what you're trying to do, what you're trying to achieve based on what this feature is supposed to be. So if I know that you're going to create like this dialogue that's going to do something or so forth, and I can see that you have created a really shitty dialogue, like it's not really doing its thing, and it has all these weird like either completely arbitrary names or structures or layers of abstraction that doesn't really fit into the overall thing we're trying to achieve, then it's very likely that either you don't really understand the problem that you're trying to fix, or like what you're trying to achieve. You have, or more likely when the juniors, it's usually that you know what you need to do, but you just don't know how to model a solution to this dialogue or this class or this service that you're trying to do, because you don't really have a good understanding of how to create efficient software that models the solution that you're trying to achieve. That's usually what I use, and this is something that you see when you can basically tell this immediately when people have copy-pasted code from, say, Stack Overflow. When they don't really know what the code is doing, usually what happens is that you see that there's a fairly big disconnection with what the code is doing, because usually on Stack Overflow or similar sorts of solutions, people have coded a solution to some other domain, like some completely other problem. Like they might have been elements there that overlap with what you're trying to do, but it's a different model. Like a classic giveaway is when you see people have, like, you know, variable names, like the data they're working with is, say, products, but all the variable names is like users or persons or something like that. It's a completely different entity that they're dealing with. That's a good sign that they've been copy pasting, because what they want is the functions and like all the abstractions that do the end thing, right? But they haven't really, and that's the thing they're focusing on. They're just trying to figure out, how do I actually make these loops and all this stuff work? So the data that they're dealing with is completely, like, they haven't reached that level of seniority or mastership of the code that, you know, the more experienced developers, like for them, like solving all of these interfaces and figuring out how to do all that stuff, that's like nothing. So they are at a higher level of thinking. They usually think about, you know, is the data structure right? Is the like, have I modeled everything correctly, and so forth and so forth? Is the logic in a good state, and so forth and so forth? But due to that they are operating at a higher level, these nitty-gritty little details on how to do things is something that you sort of skim them by. And that's usually, as I said, what happens when you understand how to solve the problem and model it correctly for the thing that you're trying to achieve. These are the main cases that I usually, this is the style of evaluation that I usually use. So as a general rule, when you see that the software that like the code very poorly fits like the conceptual solution that you need in order to deliver on the goal that you're trying to do, it's very likely that this is just a hacked piece of software where, you know, people have either just shimmed stuff in or like tried to extend upon something that doesn't really fit anymore, or they copy pasted things when you see and that's usually, as I said, when you see that they do like these really complicated arbitrary things that doesn't really seem to bring anything of value towards what you're actually trying to do. So what I want you to take away from this is that usually when you look at an engineered piece of code or a hacked piece of code, the thing that you can usually use as a measurement is that if you look at what they're trying to achieve, if it's like a new feature or like something like that, you can usually tell by how simple and how well their solution fits the thing that they're trying to do. That's the easiest. If they take a lot of extra levels of abstractions for no apparent real benefit, or if they have a problem modeling the thing, so they have like really weird names or really weird concepts within their code that doesn't really fit well with the domain that they're trying to deal with, it's usually a sign that they don't really know what they're doing. Because most software developers who gain real mastership of software development will get to understand this fundamental thing that as I was saying, that the software is a reflection of the problem that you're trying to solve. Naming is difficult for sure, but usually software developers understand like these common concepts for whatever thing that they're dealing with, whatever they're trying to model with their software. So usually the code is fairly well fitted to the thing that they're trying to do. So if you have someone who is like really pushing it with some concept where you see like layers and layers of abstractions or dry principles or like all these more like overly advanced concepts that doesn't really add much to what's trying to be achieved, it's very likely you're dealing with a philosopher. If you see that there's like arbitrary, like very messy like flows of logic that you're trying to achieve something that is fairly straightforward, it's very likely a junior who's trying to model something but they simply don't know enough about programming at this point to figure it out. And if it's a classic one, as I said, where the logic sort of does what it's supposed to do, maybe not really exactly what it's supposed to do, and you see that like the code is sort of this either really weird implementation of something, or it has like the completely wrong data structures or names or so forth, it's very likely that somebody just copy pasted this from somewhere and tried to like retrofit it into the solution, which means that they don't really know what they're doing. They're trying to find someone who knows, and then they try to figure out backwards, how do I change their solution to fit my thing, because they don't actually understand what they're trying to do. Have a great day.